Well, thanks for joining me again. Finishing off chapter 10 here, 10.3, tangents to a circle. So we're going to learn at last, they actually in the book show two rules for circle geometry, but really they're just the same rule, just flipped around. So tangents to a circle. So we need to know what a tangent line is. So the definition is here. Basically a tangent line is on a circle, if you want to just barely touch the circle in one point, right? The line is just going to barely graze the circle just in one spot, right? And so that line is called the tangent line. So if you have a line that's touching it in two different places, that's a chord. It's not a tangent. It's not running tangent to a circle. So we're going to be dealing with tangent lines in this section. Okay, so just the line that just barely touches. And so we're going to look at the relationship between that and the middle, the radius. Okay, so both rules, we'll just go through the rules and then we'll look at a few examples. So tangent to a circle. A tangent to a circle is perpendicular to the radius at the point of tangency. So in other words, if you take a line that's tangent to a circle, it will be perpendicular. It means it's going to be running at exactly a 90-degree angle to the middle of the circle. Okay, so pretty straightforward rule. The tangent chord relationship is that a chord drawn perpendicular to a tangent at the point of tangency contains the center of the circle and is the diameter. Okay, so if you're going to draw, so if you don't have that line, right, and if you draw the diameter and you cut it to the point of tangency, that means it's going to be 90 degrees. So if you know that, you can make it 90 degrees. If you know that it's 90 degrees, you know that it runs through the middle of the circle. Okay, so both kind of go together in one rule. Okay, so as always, looking at an example usually makes this a little more clear. Okay, so in the diagram, AB is tangent to the circle, so we've got this picture here. This is a line that's running tangent at point D, so that just means D is the point that's actually touching the circle. Okay, BE contains the diameter, okay, and ABE is 50 degrees, so we're showing that all in the picture. Okay, so we'll work our way through it. I find writing it out, just filling it out on the picture works the best rather than trying to do this stuff separately. So what's the measure of angle BDC? So that's our rule. The angle of BDC, if this is a tangent line and this is running through the middle of the circle, that means BDC is 90 degrees. Okay, what is the measure of the central angle DCE? So D to C to E. So we've got to do a little bit more work for this one. We're going to start with this right angle triangle. If I look at this right angle triangle here, this is 90, this is 50, which means I can figure out what that angle is. That's a 40-degree angle. Okay, it's got to be 50 plus 40 is 90, 90 plus 90 is 180. So that's one rule that you do come across, that you need to remember, that in any triangle, the three angles, A plus B plus C, always equal 180 degrees. So you're going to be asked to solve for angles a lot in this section, so you need to remember that's one rule that you need to remember. And to figure out B, what is this angle, you need to know another rule. It's called the supplementary angle rule, and the rule is that these two angles always have to be 180 as well. So if you've got a straight line, that's 180 degrees, so if 40 of it is taken up here, then 180 minus the 40 would give you what this angle is, 140 degrees. Okay, so that's B. C, what type of triangle is CDE? So C to D to E, and this really helps you to figure out what the last question is asking you, but what type of triangle? So we're talking about equilateral, isosceles, or scalene, right? And so if we notice something about this triangle, well, this point is important. It's the middle of the circle. So what can we say about this line and this line? They are both the radius of the circle. They're both coming from the middle of the circle. So if they're both the radius, that means both sides are the same. So really what I have here, I've got an isosceles triangle. So it's a triangle that has two of the sides being the same is an isosceles triangle, and I have the angle there. So what does that tell me? Well, one thing that you're going to need to know is in an isosceles triangle, this angle will always be equal to that angle. and the rules for triangles also stay the same, so 180 degrees, right? So 180 minus 140 gives me 40 degrees. So these two angles have to be the same and they have to add up to 40. So in other words, we can just do 40 divided by 2 and that gives us our 20-degree angle. So this is 20 and this one is also 20. Okay, so a little bit of work. We basically did C and D together. So D, E, C, that was asking me for that angle as well. Okay, so it's an isosceles triangle. And so using that logic, so this is important, and knowing isosceles triangles and their angles are important as well. Okay? Okay, so we'll do the show you know here. So line segment AF, so we've got another situation here. This is tangent to the circle at point E, which means then that has to be a 90-degree angle again. Okay, DF contains the diameter, and CFE is 34, so that's given to me. So what are the measures of CEF? So again, before I even start looking at this, just start filling in what you know on the picture. So CEF, that's actually my 90 degree, we already have that written down. ECF, that's this angle. So again, just like on the last example, I can figure this out by just doing 90 minus 34, which would be 56. Don't make a mistake on national television. So 56, I believe, 56 degrees is ECF. Okay, EDF, that's this other angle. And so that one we kind of have to do in 2 steps again. If I recognize, just like the last example, this triangle here is actually formed by the radius and the radius. So I could find this angle, and then I can use it to find the last one. Okay, so 180 minus 56, getting subconscious now, I'm going to use the calculator. 124, so 180 minus 56 is 124. That's this angle here. And now we've got an isosceles triangle with this one being 124. So 180 minus 124 leaves me with 56, right? And so 56 divided by 2 gives you what this angle is, 28 degrees on both. Okay? So a little bit of work with angles that we're going to be figuring out in this section as well. So we still have to remember some of the rules with triangles and supplementary angles and whatnot. Okay?